We will bring it to the fire, as you can see. It does not burn, only gradually melts. Then we'll take the ashes and dip the sugar into it. We bring it to the fire again, and this time the sugar starts to burn. Even if you remove it from the candle, the fire does not disappear, and the sugar is covered with the crust and then completely explodes. That's how it was. But sometimes sugar can burn out without exploding. Why do you think it started burning at all? Fill the glass with refined sugar to the top. And then completely immerse in it warm water. After a while, some of the sugar dissolved in the water and some remain lying in the bottom. Now, add a little potassium permanganate to the liquid. As you can see, it stays on the surface without sinking to the sugar at the bottom, even if we start to stir it. In ordinary water, potassium permanganate immediately attends to the bottom and mixes with water. No matter how much we interfere, the result is the same. And after 20 minutes, the liquid turns brown at all. Although half with sugar does not change, let's try adding green dye to one glass and iodine to another. Stir and get the same result as with potassium permanganate. And now there will be a trick. Look carefully. Let's make a number and write it on a sugar cube. We throw it into the water and stir it. Now, hold our hand over the water and the number miraculously appears on the palm of your hand. And here's the secret. We just print a number with the sugar on our finger, and then we put it in the palm of a person. That's all. Let's take a balloon and the funnel. With this help, we will pour sugar inside. Let's take a bottle of soda and pull our balloon on the neck. Try not to spill the sugar. Now we start and watch how the foam and gas quickly fill the ball. Oops! It's not easy to keep it up. Let's try it with other sodas. After all, the most powerful thing came out with cola. But now, we see that balloons inflated with gas stand and on the bottles exactly. Put a wooden board on a baking sheet and pour little sugar on top. Now add dry potassium permanganate to it. We mix these substances with the wooden stick and then we begin to crush them, turning them into a homogeneous dust. A little more pressure and a fire breaks out. What a powerful flame! In no case, do not repeat it at home. This is a very dangerous experiment. Let's take some food wrap and make 2 identical squares of it. Pour about 2.5 tablespoons of sugar on each Add a quarter spoonful of starch to one of the squares, mix, and begin to wrap in the bag. We will tie it with the thread several times for reliability. We do the same with the second film, but with the thread of a different color. Cut off the excess and put both bags in a bowl of water for 30 minutes. And then take them out. Now add iodine to the container with water and dissolve it. We will hang our bags over the solution and cover them with the lid. After 12 hours, changes are visible. Pour out the sugar for clarity. With pure sugar, almost nothing happened. But sugar mixed with starch acquired an ashen color. In a bowl, pour a few spoons of powdered sugar, and then add a little soda. Now we pour our sand on a baking tray and pour alcohol on it so that it gets soaked. Pour our mixture on top, level it, and ignite the alcohol. A chemical reaction immediately begins. The mixture begins to turn into a black mushroom-like appendicus, like monsters from TV series of One of Us. It looks creepy, but at the same time, fascinating. And that's what remains in the end. There's a charm in this figure. Let's take sulfuric acid and very carefully begin to impregnate refined sugar with it. Add a little bit and the sugar gradually begins to turn black. Continue until all the sugar turns black. Now we just watch. We see how the liquid begins to flow out of the sugar, and then it begins to deform and grow, faster and faster. Gas is already starting to be released, and the sugar itself seems to be boiling. Finally, the reaction is completed, turning the sugar into a soft, sticky black mass. It's time to conduct a larger experiment. Fill the glass jar with granulated sugar about halfway up, and now let's move on to the most dangerous part. Pour the sulfuric acid inside and start stirring everything as quickly as possible until the reaction begins. Now it only remains to observe from a safe distance. Again, the substance begins to gradually turn black, and then gas and smoke appear, after which a huge black something begins to crawl out. Somewhat resembles a slug from outer space, causes ambiguous emotions. As you can see, the mass has risen much higher than the volume occupied by sugar and acid. Let's take a closer look. Wow, this thing is hot. Break off a piece. As you can see, it crumbles easily in your hands. And load them into the clip. We load the gun and shoot the first target in the face of a Kinder Surprise. Shot! It looked a little weak, however, the foil crumbled and there was a crater on the egg. Let's try without foil. Nothing much has changed. There is exactly the same crater. Now, let's take a corn stick. Fix it as a target. 2 shots, 2 through holes. What about a plastic container? Easy penetration. Let's try another container. The gun barely managed to create a crack in it. Let's shoot the business card. No problem. And the plastic one? Not a hole, but it's cracked. Now let's check with the CD. We aim the gun and make a shot, followed by another and another. The disc split, though only on the 3rd attempt. Next up is a ping pong ball. We clamp it in a vise and load the gun. 2 shots and he just slipped out of the vise. Apparently, it is stronger than it seems. And if you put a walnut in its place, we shoot closely and it immediately breaks through the shell. How do you like our way of peeling nuts? Now we need kinetic sand. We make a small stable tower out of it. We shoot, and the bullets just bounce off. Let's make the sand a little thinner. Now, at least they got stuck in the sand while our tower collapses. The next target is a juice bag. We aim a shot and nothing. Another one and nothing happened again. But the 3rd time, we punch the Tetra Pak and the juice begins to flow out. It seems the package is seriously injured. And what will happen to a can of shaving foam? We will shoot it closely for more strength. Dents remain, we continue. We fired a whole clip, but apart from small dents, no result. It's time to take a bigger target. Let's install watermelon on a stump and point a gun at it. Start shooting. Bullets enter the peel and even get stuck in it. But you need to keep shooting. We're on the right track. It seems that the pulp is already visible. Let's remove the stuck pellets, and seems we were really able to break through the peel. It even has juice flowing out of it, but it took a lot of shots. And now, let's light a candle with the match and try to extinguish the fire with the shot. The main thing is to aim. Bam!